So, good afternoon. I don't know if Martha is listening still, but that was really good. What she did, she set the broad, scope for the standards, uh, for the future. What my presentation is, I'm going to focus on low-rise residential building, which was the focus of 2019 standards. But in the meanwhile, I'm going to repeat some of the information that yeah, it's under Shirakh, Shirakh. And so mine has a low-rise residential focus. I wanted to recognize the contribution of my colleagues, Christopher Meyer, Bill Pennington, Payam Bozachemi, and Danny Tam. So we set 6 goals for ourselves when we started this process: increase the building energy efficiency as cost-effective as possible. And this was the reason why we introduced new concepts into the building standards, such as high performance attics and walls, which is actually new in California. Contribute to the state's GHG reduction goals. Martha talked about that. Substantially reduce the home's impact on the grid through efficiency and PV system that's grid harmonized, and providing independent compliance paths for both mixed fuel homes and all electric homes. When we started this process, there was several barriers that prevented the construction of all electric homes. And with the 2019 standards, we removed all those barriers. We also provided tools for Part 11 or the REACH codes to actually achieve more energy efficiency than Part 6. And we think we've actually accomplished our 6 goals. A little bit of history is, sorry. Next slide. Next slide, we're on the one says ZNE strategy. This started about 12 years ago, actually under administration of Arnold Schwarzenegger. And ZNE back then was a simple concept: make a building that's very efficient, the envelope and the appliances, and then install some amount of renewables, PVs, that would net out the total energy of the house. That includes electricity and natural gas on an annual basis using TDV as a metric. Next slide, lessons learned. It turns out that reality is always more nuanced than what people originally envisioned. We've learned a lot in the intervening 10, 12 years, and a lot has happened. For instance, large-scale utility deployment as a result of the 50% RPS that Martha was talking about. We also had emergence of net energy metering rules, NEM 1, and then the subsequent NEM 2. And NEM actually is the law. ZNE was a goal. It was an aspirational goal. NEM is the law. So we have to combine. And as one speaker this morning said, we achieved partial ZNE. Well, it's because of NEM rules. They don't allow you to oversize relative to the electricity load at the house. And we also have time of use compensation rate schedules, which also influenced our decision. And the problem with the NEM rules and most of these strategies is that it's the net part of it which is causing the problem, because it's done, the netting is done on an annual basis. It assumes that the grid is this vast storage where you can overgenerate in part of the day or part of the year and then use it some other time. And we know that's not true. You cannot overgenerate in summer and send it to Arizona and Nevada and assume you have that benefit in the winter when sun's not around. So we need to get away from this concept of annual netting and to a more realistic, which is probably hourly netting. And I've heard Commissioner McAllister talk about this several times. So the other concept that we are considering is promoting grid harmonization strategies, is to basically harmonize the customer-owned PV system with the grid. And there's different definitions or citations. People talk about grid harmonization, grid integration, grid citizenship. They all mean a little bit different thing, but for Title 24 standard, we have a very specific definition in mind, which is actually here. It's underlined. It says grid harmonization are strategies and measures that harmonize customer-owned distributed energy resource assets with the grid to maximize self-utilization of the PV output and limit grid exports to the period that are benefit to the grid and the ratepayers. And we think this is the way you can actually maximize benefits to the grid, to the environment, and to the occupant. Next, 2019 standards approach is therefore number one is envelope efficiency. Number two, appropriately sized PV system. And what does that mean? A right-sized PV system, the way we define it here, is a PV system that displaces the annual kilowatt hours of the house in a mixed fuel home. So that's how we define it. And then leveling the playing field for all electric homes. And number four is grid harmonization strategies. Next, PV cost effectiveness. All measures that end up in the building standards, they must be cost effective, whether they're efficiency or generation. So the PVs are not exempt from these rules. We use life cycle costing analysis, but for PVs, we also have to consider both NEM sizing rules and NEM compensation rules, which is very complicated, but in short, if you oversize your PV system, and I think another speaker this morning mentioned that, they're over generating, but they only get 3 cents per kilowatt hour. So we don't want to oversize relative to the annual kilowatt hours of the house. And so that's how we ended up with the PV criteria that we did. Next slide, here comes the sun. So putting all that together, for the first time in Title 24, we proposed and the Commission approved prescriptive PV requirement that sized to displace the annual kilowatt hour of a mixed fuel home. We have several exceptions and variances for this. For instance, if a building is being built in that's shaded due to an external obstruction, another building, trees, hills, and so forth, they are exempt from the standards. We also have variances for multi-story buildings, 2- and 3-story, if they don't have enough room on the roof to accommodate the prescriptive requirement. They're not exempt from the requirement, but they get a lower threshold. And we work with the builders and architects to make sure the numbers that we recommend are actually workable. And next slide, I'll follow this on. The building standards are constructed in a way to give the builders the maximum flexibility to get to the target EDR or performance level, whether we're talking about building envelope measures or PVs. For instance, for high performance attics and walls, there's probably 10 different ways, they can get there, or they can actually do trade-off against other building features. For PVs, rooftop installations got the most publicity when we adopted this, and that's the option that created most of the feedback that we received, some good, some bad. But that's not the only option in the standards. For rooftop, there are actually 2 options. There's an outright purchase, which is what got reported in the news media. But there's also a lease or a PPA option. And they're both equally valid under the standards. And the builder can choose depending on their the preferences. With outright purchase, you have a larger initial investment, but you have also larger monthly savings. With lease and PPAs, you have no initial investment or very little, but you have smaller monthly savings. So this is was one of our answers to low-income advocates who objected to that $10,000 or $9,500. You can go to a PPA option or lease. And there's also a community solar option that we're hoping that this is going to become available. We're working with several utilities, including SMUD, and also some CCAs. There's going to be some very creative thinking going into this, and I'm really hopeful that community solar would actually become a viable alternative to rooftop PV. And stay tuned. I think the next 6 months is going to be very exciting. So next slide, community shared solar / renewable. So the requirement for community solar is spelled out in section 10-115. So if you're going to propose a plan to us, it must meet these requirements. For one thing, even though it's called community solar, the resources that goes into that does not necessarily have to be any renewable resource can actually work. So this could be solar, it could be wind, it could be geothermal. So all of that is actually cool as far as we're concerned. But in addition to that, the systems must have an energy performance, the kilowatt hour reduction, as if it was a rooftop system. So because it's replacing a rooftop system, it must perform, at least on the customer bill, as if it is a rooftop system. Okay, we got, it has to be dedicated to the building. You cannot move with the customer. It has to stay with the building for 20 years as if it's a rooftop system. And a cost saving, that's actually an important thing. Cannot cost the occupants more than a non-participant. So this is different than a rooftop system. What we're saying here is that if a customer is participating in a community solar, they cannot, the utility or the provider cannot charge him more than the neighbor who's not participating in a community solar and doesn't have a PV system. So that is the key thing here, that that's where the creativity comes in. So if I am a neighbor that don't have a PV or not participating in a community solar, but my neighbor is, his bill should not be more than mine. The green tariffs and all that, they're all good, the GTSR, but the problem is currently they charge a premium. And so we're working with them, to find ways. I'm going to ask a couple of questions because I only have less than 10 minutes. Go ahead. I was wondering if you mentioned the rate cannot be higher or the total bill? The total bill. The total bill. Good question. So next, Joint Appendix 11 and 12, very important documents. I'm not going to talk about it here, but if you're installing PV system and battery storage system to comply with the 2019 standards, you need to become very familiar with JA1112. JA11 is for PV system. JA12 is for battery storage system. The batteries that are going to be installed to get compliance under this standard, they must comply with JA12. They cannot be a static device that's only used for backup power. JA12 is what makes these batteries into a dynamic, responsive system. And there's different control strategies, basic, TOU, and advanced. So, I suggest that you read this and become very familiar with it. Next.
Does that also include thermal storage?
It does include thermal. So we do give credit to thermal storage and battery storage. Well, the JA12 is only for battery storage, I should say that. But there is a credit using our software for both thermal storage and battery storage. So that's the clarification. We're using billing on Energy Commission's design rating tool. So we're going to move away from our traditional way of demonstrating compliance to using energy design rating and to align with ResNet. And by definition, we're using a 2006 IECC as the base home, and a building must pass 2 EDR score. One is for energy efficiency, and the other one for demand flexibility, PV, and storage. So the building has to pass both of those. Why we're using EDR? Because EDR is a performance target. And we give the builders that target, and the builders can get to that any way they want. So it provides maximum flexibility, and that's why builders like that. Next, targeting EDR and compliance tool. This is the screenshot that kind of, this is the output from our software, CBAC Res. Really good software, very powerful. You can use that to model the traditional envelope and mechanical equipment. On top of that, you can use this software to basically model your PV system, your storage, all demand responsive and demand flexibility features, and it has all kinds of reporting tools, and I'll show you some of those. Um, and what this slide has is a lot of cool information about the actual load of different the kilowatt hours of different loads in the building, and you can see here like the space heating, how many kilowatt hours is used, how space cooling, and you can go down and look at the plug loads. What's interesting is in California, our dominant load in most of our climate zones are not heating, cooling, or water heating. They're the plug loads, appliances, and
Are those things now included in the EDR that you have to,
yes.
you have to count your plug load and you get credit?
As long as the software allows it. So, you can actually do the adjustments to lighting, and then we may have some allowances for Energy Star appliances. All electric option, PV size. So, we said the right size PV system is based on the electric portion of the mixed fuel home. So what happens you go to an all electric home? What happens to the PV requirement? It stays the same. It's still based on the mixed fuel home. So if you're building a home that was mixed fuel with 3 kilowatt hour with a 3 kilowatt PV system, if you go to all electric, it still stays at that same 3 kilowatt. Reason for that is if you double the amount of PV system, that actually becomes a disincentive for all electric homes because you're increasing the cost of that building. Now, the builders and the homeowners at their discretion can put in a larger system if they want. We're just not making that a code requirement. Next slide, resistance is futile. We've heard actually from serious people that they came to us and said, hey, the PV is coming down in price, is too cheap to meter, so why not we use electric resistance for heating and space heating? And then our answer was, no, if you want to go electric, it's cool, but you need to use the heat pump water system, and therefore resistance is futile. 3 minutes, don't judge me by my size. That's, the average PV that's going to go into the buildings is about 2.8 kilowatts for a newly constructed 2019 compliant building. The average PV system that's going into the existing home is 7.2. So that's what right sizing does for you. So even though this is a much smaller PV system, but don't underestimate it, because we think a smaller right-sized PV system that's grid harmonized brings a more cost-effective and more benefits to the grid and the environment. And in the table, you can see, depending on the climate zone, what the average PV system might be. For instance, in climate zone 1, which is here, it's about 3.4. If you're going down to Sacramento, that's about 3.1.
Essentially double that.
Yeah, you can double it, but again, we're not requiring it. You can do it. Next slide, CO2 reduction in buildings. You can see how in an existing buildings uses about or generates about 6.5 metric ton of CO2, and with 2019 standards, with the right size PV, we can get really close to zero. 1.0 for an all-electric home, and if you go to an all-electric home with PV and battery storage, you can get down to 0.2 metric ton from an existing 6.5. So we've moved in the right direction. The next one, CO2 reduction in buildings. This is for mixed fuel home. What CBAC Res now allows you to do is generate this graph. We've all seen this graph using kilowatt hours. These are all in CO2, kilograms of CO2 generated for different loads. So this first slide is for a mixed fuel home. And basically what it tells you is that the largest load that's generating carbon dioxide is first is space heating. Second one is plug loads. The third one is water heating. For mixed fuel home, if you go to the next slide, this is for an all-electric home, and you can see how all-electric shrunk the percentage of the water heating and space heating, and therefore plug loads actually become the dominant loads. The next slide, CO2 reduction with building, that has a graph with it. That's slide number 20. This is a cool slide. This is why hourly netting is so important. What this has is the red graph and the blue graph. These are, again, CO2 generated per hour for that building for August 6th. This is a building in Sacramento, California. What the red graph is a 2019 compliant building without battery storage. And what does that graph look like? Even though it's a CO2 generator, it's a dot curve. Even though dot curve is a kilowatt hour, it's an energy metric. But when we even transfer it into CO2, it still looks like a dot curve. So with that's the problem with the annual or daily netting, that you're generating more in part of the day, and then you got to get into the belly of the duck you're exporting, and somehow you're assuming this is all good. But here, what the blue line indicates is we're adding a 14 kilowatt hour battery storage, and look what happens to that line. It's hugging that zero line for the entire 24 hours, except for a few hours in the morning, and that's because people are getting up and taking a shower, and the heat pump water heating is kicking in before the sun comes up. So that's the difference between hourly netting and annual netting. That's why we need to go to an annual netting. Grid harmonization becomes important. So